And now we're ready to put these two rules together. So a little mixed practice when we're multiplying and dividing. So in these problems, we'll see both operations possibly being used. So here we go. Our first example, t to the third times t to the 10th, all divided by t to the 7th. So we see multiplication and we see division. Couple different ways you could solve this problem. I always like to find my numerator, and if I can condense my numerator, I'm going to do that. So here I'm going to combine t to the third times t to the 10th using my multiplication rule. So this is going to give me, I'm going to keep the common base, which is t, and then remember, multiplying, I'm going to add my exponents. So 3 plus 10 gives me t to the 13th, and now I'm just going to bring down my t to the 7th. So I have no more multiplication. All I have is division rule, keep my common base. I'm going to subtract my exponents. 13 minus 7 is going to give me 6. So that big example now condenses and simplifies to t to the 6th. How about this one? So it gets a little more complicated here. Let's break it apart. We have 3x squared times n to the 4th, all divided by 3x times n to the 2nd. So if I look and see, last time I worked with my numerator first, there's nothing I can do my numerator this time because we don't have common bases. We have an x and we have an n. Remember, I can't use that rule if these bases are different. However, what I'm seeing is I have common bases if I use division. So for this example, I'm going to break it up and I'm going to actually use division first. So forget about the n's for now. 3x squared divided by 3 to the x, or 3x, I'm sorry. Use your coefficient rule of 3 divided by 3 is going to give me 1. Keep my common base, which is x. And then here I have an exponent of 2, and I don't see an exponent. Remember, if I don't see an exponent, it's always 1. So I always like to put that 1 there so I don't forget. 2 minus 1 gives me 1. So I could also write this as simply just x, right? 1x to the first is exactly the same as x. So either or there. I then have my multiplication of n to the 4th divided by n squared. Keep my common base of n. 4 minus 2 gives me 2. So I could also write it like this, which is equivalent to this, which is also equivalent to xn to the 2nd. Because remember, if I see these two variables here, there's really a multiplication symbol there. On your assignment this week, you'll also see a question, true or false. So we're going to have you use these rules here to tell us, is the statement true or is it false? So x to the 8th over x to the 3rd, is that equal to x to the 19th over x to the 14th? Well, if I'm trying to say that the left side is equal to the right side, we see division. So let's use our division rule and see where we get. Common bases of x, subtract your exponents. 8 minus 3 is 5. Okay, so the left-hand side simplifies to x to the 5th. Let's see what this right-hand side simplifies to. X to the 19th divided by x to the 14th also gives me x to the 5th. So are they equivalent? They are. This is true, and this would be my justification. I use the division rule.